Hi, I'm Nathan Oakley, and this is literally 3 minutes after the finish of Flat Earth debate number 82, I believe it was. And I've still got Anthony Riley with him on Skype. He wants to explain something, so I'm recording this for prosperity. Over to you, Anthony.
Really, that hangout, Paul dominated it with maths, and I really wanted to talk about the physics, because it's the physics that gives you the maths, and then the maths then you can apply and see, does it give you anything useful? And it appears that the physics that the maths is being applied to is not the correct maths. So the physics is different and the maths is different to what it should be. Now, I've got on my screen, I've got two papers. One's atmospheric refraction, dated 2012, and it's from MIT. And the second one is similar paper, Simulation of Atmospheric Phenomena, but this is dated 2006. The 2006 one on the right is what Mick West cites, and there's value in this, and we should be talking about the content of both of them. But essentially, I'll deal with the one on the right first because it's the quickest and the easiest one. They base their simulation on the application of Fermat's principle, which is basically the physical. Oh, hang on, let me just move that over a little bit. The physically based description of the light path through a non-homogeneous medium with a continuously varying index of refraction, coupled with a fast, efficient numerical resolution method. This is their simulation. It's based on that particular point. There's a couple of other points. But on the first image, we have this, on the first article, we have this other article, which is more recent, 2012. And it's what it basically talks about is much more maths than what Paul was talking about. And it's to do with the light trajectory. Rather than the atmospheric conditions, it's the path that the light takes. So forget about the pressure, the temperature, the density and all that for the moment. Although I agree with that maths in regards to the atmosphere, my question is the light, because we're talking about the light and how much it bends according to their model. Now, in this article, it doesn't talk about bending light going down. It talks about bending of light in all directions, up, down, left and right, which is a problem because the maths that Paul cites is only based on the maths bending down. Now, I asked Paul at the end of the hangout, why was Fermat's principle not being applied? There's a specific point in Fermat's principle that the trajectory of light should be based on. And it doesn't appear that Paul's applying that. He's applying all the atmospherics. That may well be valid, but it doesn't appear to be applying the science. The science appears to be Fermat's principle should be being applied. Now, in this paper, it talks about the equation of trajectory using Fermat's principle. Okay. Now, I asked Paul, why was it not being applied? And I didn't expect an answer immediately. But I do expect an answer because it appears that you should be applying this formula. Now, I say it appears because I'm stupid. I'm a flat earther. I don't know what I'm talking about. But I can research stuff. And it appears that this is the formula. Now, it talks about a lot of stuff in here, but it's a straightforward formula. Hey, up. I've got someone ignore that for the minute. It's a straightforward formula, but it's been expanded. So it appears that this would be the standard refraction calculator, and it appears that this will be the non-standard if it gets expanded, or some other interpretation. But my question to Paul was, why is this not being applied? Now look at how crazy the maths is. It's really crazy. But the reality is we can apply the simple maths that's in this, applying the Fermat's principle to the actual light. But nowhere in this article, if I do a control and F now and find, nowhere in this article does the word radius appear. Radius brings back a zero value. So again, all the maths that's based on anything to do with the radius of Earth appears scientifically from physics not to be relevant maths. And I put it to Paul that applying radius to the mathematics on the calculation of standard refraction, that's the 7.6R bit, is completely red herring, because your own maths and your own science is telling you that Fermat's principle on the trajectory of light is what you should be applying. Why is that not being applied? That does not look difficult, and it doesn't involve the radius of the Earth. Where does the radius of Earth come from? Why are you applying it? It doesn't appear to make any sense. It's not based on science. It's based on something else. Ultimately, the question is it based on fake? Is there a radius or not? Why is your own science not applying the principles of radius or geometry? It's talking about the speed that light gets through a particular medium, how much it bends, and it doesn't always bend down. It bends in all directions. It bends up, it bends left, it bends right. And when we apply the Skunk Bay footage, that's consistent with what this paper's talking about. So again, my question is, why is Fermat's principle on the trajectory of light not being applied? It's really simple. It's a simple formula, doesn't talk about the radius of the Earth. Why is it not being done? That's it.
Well, thank you very much for that. I'm going to say a massive thank you to all of the audience for watching. Be sure to like, comment, share and subscribe. Thank you to Anthony Riley. I've been Nathan Oakley, and I'll see you all in the next video.